Newton's first law of motion. Newton has three laws of motion in classical mechanics. Just like his legendary name, his laws of motion are also as legendary and interesting at the same time. These three laws of motion have set the basic for understanding the classical mechanics. Today we will discuss the first law of Newton. The first law of Newton tells us that if a body has a net force equal to 0, so the acceleration of the body will also be equal to 0, and the state of the body won't change at all. So if a body is at rest, it will remain at rest, and if a body is in motion, so it will keep its uniform motion. By the uniform motion, it means that the body won't change speed or direction, or simply we can say that the velocity of the body will be constant. The rest part of the Newton's law is pretty common and easily observable by us. This part of Newton's first law tells us that if a book is on the table at rest, so it will remain at rest as long as there is no external force acting on it. And it's pretty common observation in our daily life. But all the confusion starts with the second part, which is about motion. When usually we throw a ball, at first it is faster, but then the ball gets slower and slower until it stops. So this observation is against Newton's first law of motion. But here you have to be careful that the Newton said that the net force should be equal to 0. But in this case, the initial speed applied by the hand is no longer there, and the ball should keep its motion. But here comes all the other forces like friction and air drag force, which is acting against the direction of motion and make the ball to stop. But when you do this experiment in space, where there is no drag and frictional force, the ball will move with uniform motion all the time. This law of Newton is also called law of inertia. Inertia is the idea that the object will continue its current state until some forces causes its speed or direction to change. Mathematically, we can write it as that if a force is equal to 0, then acceleration on the object will also be equal to 0. This is for the first law of Newton.